Hello everybody, my name is Frank Powell. I'm from the University of Zurich and I would like to present you my poster in slide form named Strongly Increased Glacier Retreat in Franz-Josef-Land, Shape of Things to Come. I would also like to acknowledge my co-authors, Yvonne Schaub and Philipp Rassner, who have strongly contributed to this work. On this picture, you already see in the background the islands, a few of them at least, of Franz-Josef-Land, which are mostly governed by flat ice caps. This is a quite remote place and maybe also a little bit a mystic place. There's not much known about Franz-Josef-Land, a little bit. It's partly certainly due to its remote location in the middle of the Russian Arctic, north of 80 degrees north. It's a collection of very, very many islands, and usually these islands are snow-covered at the end of the ablation period, so glacier mapping is not so easy. However, in September 2016, the situation was a little bit different, and many of these ice caps had lots of bare ice exposed, and if you look at this one here, you see that there's even no snow left on device. So very good conditions for glacier mapping, but very, very bad conditions for the ice caps. Here in the center is Luigi Island, and I will show you this in a little bit more detail in a second. Here's just another picture showing that there is some snow left, mostly at the higher elevations, but at the lower elevation ice caps that you see here to the left of the image, there's no snow left. So here for Luigi Island, we have first created a glacier inventory. So using a simple bend ratio to map bare glacier ice and snow, which means we have used the near-infrared band. In this case, we have used the red band and the shortwave infrared band, divided the two to get this ratio image. And as you can see, glaciers do not really pop up very well. So when applying the threshold, we get this, including all the oceans. And this could be removed with an additional threshold in the blue band, so that after some filtering, spatial filtering, we get these glacier outlines shown here in yellow. Additionally, we use the digital elevation model, the Arctic DEM, to obtain drainage divides, and you see them here on top in black, and compared to those from the random glacier inventory in red, you see that there are quite some shifts, and I would say the new ones are a little bit more precise than the former ones. So with this, we have a new glacier inventory, and we have actually created two inventories. One is divided by drainage divides, giving 919 entities, and 50 major ice caps when we remove the drainage divides, color-coded here for size. So the largest ones are in blue, and the smallest ones are in orange to red colors. So coming to the area changes, we found that these took place mostly for the glaciers calving into the ocean. You see here an example, and also here's an example, with very little or limited change for the glaciers that are terminating on land. And here another example with lots of retreat, several kilometers in many cases, for those glaciers calving into the ocean. So when counting this together and comparing it to former inventories, here shown for the former Russian inventory, taken from the satellite image atlas of glaciers of the world, and calculating the area changes for these three periods from 1952 to 2005, let's say, middle of the RGI, and then to 2016, we get the numbers you see to the right. And here in particular, you see the strong acceleration of glacier area loss by about a factor of 3 over the recent decade. So we have created a new glacier inventory for Franz-Josef-Land using Sentinel 2 scenes with sea ice and snow-free conditions. The outlines were mostly acquired in just one day instead of 10 years, as in the former inventory. We used the Arctic TEM to derive topographic information and improve drainage divides. The area loss was particularly strong for calving glaciers, with little change for land terminating glaciers since the RGI. And the area loss was strongly enhanced during the past decade by about a factor of 3. With this, I thank you for the attention.